In 1939, the Pennsylvania Railroad unveiled the largest passenger steam locomotive ever built, a machine designed to be the future of American rail. Within a few short years, it was scrapped, and this is the story of why. In 1937, the Pennsylvania Railroad's motive power department faced an internal crisis of performance. On the newly electrified Northeast Corridor, the revolutionary GG1 electric locomotives were proving what modern high-speed passenger rail could achieve. But west of Harrisburg, the railroad's vast system remained unelectrified. On these steam-powered routes, the flagship passenger trains still relied on the aging Class K's Pacific and designed before the First World War. These older engines were struggling under modern demands. As passenger cars transitioned to heavier steel construction and train lengths grew, the K-Force often required double-heading, coupling two locomotives to a single train, which doubled labor costs and complicated operations. The head of the Motive Power Department, John E. Bennett, issued a demanding engineering brief to solve this operating bottleneck. He wanted a steam-powered answer to the electric GG1. The specification was uncompromising: a single coal-burning steam locomotive that could haul a massive 1,350-ton passenger train at sustained speeds of up to 100 miles per hour on flat terrain. To realize this vision, the railroad took an unusual step. Rather than commissioning a single manufacturer, they formed a collaborative consortium of the country's three rival locomotive builders: Baldwin Locomotive Works, the American Locomotive Company, and the Lima Locomotive Works. Working alongside Chief Mechanical Engineer William S. M. Katz, the engineering team split the technical challenges. Baldwin engineered the massive boiler and its high-pressure steam systems. Alco developed the cylinder and valve gear layouts. Lima fabricated the advanced running gear. By dividing the mechanical load across two independent sets of driving wheels on a single, rigid frame, they believed they could eliminate the destructive vertical hammering, known as dynamic augment, associated with heavy traditional steam engines at high speed. On January 31, 1939, after months of intensive design work, the colossal machine emerged from the Juniata shops in Altoona. Designated the S1 and assigned road number 6100, the experimental prototype cost a staggering $669,780. It was the most expensive and ambitious steam experiment the railroad had ever attempted. The physical reality of S1 number 6100 immediately earned it a simple, direct nickname among the shop crews and rail workers: the Big Engine, and it was indeed colossal. From the front coupler of the engine to the rear coupler of its massive 8-axle tender, the S1 stretched an astonishing 140 feet, 2.5 inches. This made it the longest passenger steam locomotive ever built, longer than 3 modern school buses parked end to end. On its own, the engine weighed 608,170 pounds. When carrying a full load of 26 tons of coal and over 24,000 gallons of water, the combined weight of the locomotive and tender ballooned to 1,060,010 pounds. The core of this mechanical giant was its singular, unprecedented wheel arrangement, a 6-4-4-6 configuration cast into a massive, rigid frame. Unlike articulated locomotives, which were hinged to bend through tight curves, the S1's frame was a single, unyielding piece of steel. Under white notation, this meant the S1 rested on a 6-wheel leading truck for high-speed stability, followed by 2 separate sets of 4 driving wheels, each set driven by its own independent pair of cylinders, and finished with a 6-wheel trailing truck to support the massive firebox. The driving wheels themselves stood a towering 84 inches in diameter, fully 7 feet tall, dwarfing the average worker standing beside them. This wheel layout was exclusive. No other locomotive in railroad history, before or since, was built with a rigid frame 6-4-4-6 design. The Pennsylvania Railroad had constructed a mechanical titan of unmatched proportions, an engine designed to dominate the rails by sheer physical scale and engineering power. The decision to build a rigid-frame duplex, rather than an articulated locomotive, was a deliberate calculation by Chief Mechanical Engineer William S. M. Katz and his design team. Articulated steam engines, like those used on western mountain routes, utilized a hinged frame to bend through sharp curves. While excellent for low-speed freight hauling, this pivoting joint introduced lateral instability at high speeds. For a passenger locomotive built to sustain 100 miles per hour, any lateral swaying was unacceptable. Instead, Katz opted for a single, unyielding steel chassis. To deliver massive horsepower through this rigid frame without destroying the tracks, the team split the engine's power across two independent cylinder sets. In a traditional steam locomotive, a single pair of massive cylinders turned all the driving wheels through heavy, long side rods. At high speeds, the weight of these reciprocating rods created a destructive vertical pounding known as dynamic augment, or hammer blow, which literally battered the steel rails beneath. By dividing the machinery into two smaller groups, the duplex design allowed for much shorter, lighter coupling rods. This minimized reciprocating mass, balanced the forces, and promised an exceptionally smooth ride at speed. The Pennsylvania Railroad engineers fully understood the trade-offs. They prioritized high-speed stability and structural alignment over the flexibility of a hinged locomotive. The rigid duplex was a purposeful bet on straight-line speed, a choice that met its immediate mechanical goals, even as it set an unyielding boundary on where the engine could physically travel. In 1937, as the engineering blueprint for the colossal locomotive took shape, the Pennsylvania Railroad sought to turn this physical giant into a grand corporate statement. The railroad commissioned industrial designer Raymond Loewy to craft an exterior that would define the future of passenger rail. While the builder consortium calculated boiler pressures and wheel loads, Loewy focused entirely on styling and public image. His role was strictly aesthetic, keeping his work separate from the mechanical authorship of the engine. His task was to clothe a 300-ton steam machine in the visual language of tomorrow. To do this, Loewy designed a continuous wrap around Art Deco shroud. The steel casing featured a sharp, tapered rocket nose and long, horizontal accent strips that made the engine look fast even when standing completely still. This shell was more than mere decoration. It was a strategic exercise in brand identity. Working closely with the railroad's Vice President of Marketing, John R. Miller, Loewy envisioned the S1 as a rolling billboard for the company's modern era. His studio drafted sketches that eliminated the cluttered pipes, domes, and pumps typical of traditional steam engines, replacing them with a smooth, unified casing. Every line of the cladding was meant to distract the public from the reality of coal soot, replacing it with the romance of luxury and speed. This styling transformed the S1 from a complex piece of industrial hardware into a work of public art. Even before the massive driving wheels turned on active main lines, the sleek silhouette guaranteed that the locomotive would become a public spectacle, turning a mechanical prototype into a legendary symbol of progress. On April 30th, 1939, the gates of the New York World's Fair opened to a public eager for a glimpse of tomorrow. At the heart of the Railroads on Parade Pavilion, standing on a massive elevated platform, was the S1. Designated the locomotive of tomorrow, the engine did not sit static. Mounted on a heavy treadmill system, its 84-inch driving wheels spun at simulated high speeds under its own steam, sending a rhythmic chuffing through the fairgrounds while remaining stationary. The branding on the locomotive's flank made a bold statement. Instead of the traditional Pennsylvania Railroad lettering, the tender bore the words American Railroads in clean, gold, sans serif script. This was a deliberate branding gesture, funded by the Association of American Railroads to present the S1 as a shared achievement representing the collective power of the domestic rail network. As the massive steel rods plunged back and forth, the locomotive stood as a physical representation of industrial strength and corporate optimism. Its seamless casing, free of visible pipes or pumps, gleamed under the fairground lights, drawing crowds that stood captivated by the kinetic energy of the turning wheels. For the millions of visitors who walked the Flushing Meadows grounds between April 1939 and October 1940, the S1 was the center of attention. It promised a world of limitless speed and effortless luxury. This was the peak of the locomotive's public life, a moment of pure celebration where the immense engineering risks and physical scale of the machine were honored before the realities of active rail service could intervene. To put the S1 on display in New York, the Pennsylvania Railroad had to face an immediate, embarrassing problem. The giant locomotive could not actually reach the fairgrounds under its own power. Its 16-foot height and extreme width made it impossible to pass through the railroad's own North River tunnels into Manhattan, where it would strike the tunnel ceilings and Penn Station platform edges. Instead, the engine was towed deadhead from the Juniata shops in Altoona, pulled eastward by an L1S Mikado, and flanked by two P70 passenger cars. Once it reached the New York terminal area, the only path capable of accepting its colossal proportions was the Long Island Railroad. Even on this route, the transfer became a painstaking, slow-motion struggle. On July 19, 1939, the convoy crept onto L1RR tracks. Along the Atlantic branch, crews had to temporarily dismantle station canopies and lower platform awnings at Woodside and Jamaica just so the 7-foot driving wheels could squeeze past. At several low road-grade bridges, engineers had to lift steel bridge girders and raise overhead decks. To cross the East River on the Queensboro Bridge, workers shifted the rail catenary and guardrails outward. The S1 crossed at a maximum speed of just 5 miles per hour, clearing structures by mere inches. This slow crawl through Queens became the first real warning. Long before it ever pulled a commercial passenger train, the S1 had already forced the physical restructuring of the railway line it traveled. The machine was designed for a world that simply did not have room for it. When the New York World's Fair closed in October 1940, the S1 moved from its display pedestal to face the realities of active rail service. The Pennsylvania Railroad discovered that the physical geography of its network would not yield to the grand scale of its newest locomotive. The core of this conflict lay in the mathematics of the engine's chassis. The S1 did not bend. Unlike articulated locomotives that used a hinged frame to snake through tight curves, the S1 relied on a single, rigid steel bed. The rigid wheelbase, the distance between the front and rear driving axles, extended over 28 feet. This unyielding span meant the locomotive required a minimum curve radius of 15 degrees, or roughly 1,800 feet, to operate safely. While this standard was achievable on straight, flat runs, the reality of the Pennsylvania Railroad's network was far more complex. Developed over decades to traverse rugged terrain and pass through dense industrial cities, the system was filled with sharp curves, tight terminal yards, and complex junctions engineered for much smaller steam engines. On these standard curves, the S1 became a destructive force. As the rigid frame entered a turn, the massive driving wheels exerted tremendous lateral pressure against the steel rails. Instead of following the curve, the heavy axles pushed outward, threatening to spread the tracks apart, break the tie plates, or shear the metal spikes holding the line together. The 3-axle leading and trailing trucks, designed to guide the locomotive, could not fully absorb these immense lateral forces. On multiple occasions during early trials, the S1 simply climbed over the outer rail and derailed on ordinary curves, bringing entire divisions to a halt. Even the specially constructed Ys built to accommodate the engine suffered repeated derailments when the massive frame refused to conform to the track. This geometric mismatch was not a failure of ambition or mechanical power, but an inescapable conflict of physical dimensions. Because the S1 was too long to fit on standard turntables, crews could not turn the engine at existing facilities. The railroad had to construct custom 3-track Ys at select locations just to reverse the locomotive's direction, an expensive operational burden for a single prototype. The restriction extended far past the curves themselves. The engine's height and width prevented it from fitting into standard roundhouses for routine maintenance. Mechanics had to service the massive machine outdoors or in specially modified stalls, exposing sensitive components to the elements and complicating daily inspections. The S1 had been built to pull flagship passenger trains across the entire length of the system, but its physical footprint isolated it from the vast majority of the tracks it was meant to serve. Before the boiler could prove its efficiency, or the duplex design could demonstrate its high-speed stability, the infrastructure of the railroad itself had drawn a hard, unyielding line. The longest passenger locomotive ever built was simply too large for the world it had to operate in, establishing its size as the first fatal flaw of the entire experiment. On the straight, open tracks of the Fort Wayne division, engine crews ran into a dangerous physical limitation of the duplex design. The locomotive could not keep its grip on the rails. The S1's massive 84-inch driving wheels were built for high-speed cruising, but they carried only 47% of the engine's total weight. The rest of the weight rested on the massive six-wheel leading and trailing trucks. This uneven distribution severely reduced the locomotive's traction. Whenever an engineer opened the throttle, especially on wet or oily rails, the driving wheels would break traction and spin violently. This wheel slip occurred at starting, but it also happened at high speeds, sometimes while the locomotive was cruising at 80 miles per hour. In a traditional steam locomotive, a sudden wheel slip was easy to detect. The entire engine would shudder, and the draft in the firebox would drop, instantly alerting the cab. But the S1's duplex design split its power between two independent machinery sets on a single frame. If the rear set of driving wheels began to slip, the front set would continue to pull steadily. This masked the loss of traction. The heavy mass of the locomotive absorbed the vibrations, leaving the crew unaware that half of their engine was spinning out of control. To catch a slip, engineers had to constantly monitor two independent pressure gauges and listen for subtle changes in the exhaust cadence. By the time they realized the wheels were slipping, the mechanical damage was already done. The consequences of these high-speed slips were severe and expensive. The violent spinning ground flat spots into the steel tires of the 84-inch drivers, requiring mechanics to regularly lift the massive machine to reprofile the wheels. The rapid, uncontrolled revolutions also battered the rod bearings and shook the heavy valve gear loose. On the tracks, the slipping drivers literally burned the railheads, leaving deep, scarred divots in the steel. Maintenance crews had to frequently grind the rails flat again, or replace entire sections of damaged track. Instead of a smooth, powerful passenger engine, crews spent their shifts fighting the machine, backing off the throttle just when they needed to maintain schedule. The big engine was tearing itself, and the railroad's infrastructure apart. In April 1941, the Pennsylvania Railroad's Motive Power Committee accepted the limits of their creation. They issued an official directive that formally confined the S1 to a single, specific segment of the network, the 223-mile corridor of the Fort Wayne division between Chicago, Illinois, and Crestline, Ohio. This flat, straight stretch of track was the only territory where the giant locomotive could run without triggering clearance disasters or climbing off the rails. This restriction is the origin of the popular idea that the locomotive was banned. No government agency or safety board outlawed the S1. Instead, the railroad effectively banned the locomotive from its own system. Fort Wayne Division Superintendent circulars, including a directive in June 1942, instructed dispatchers to reject any routing that would send the engine east of Crestline. The restriction was a permanent operational boundary, keeping the S1 locked in the Midwest until its retirement. The decision revealed a stark institutional irony. The Pennsylvania Railroad had spent nearly $700,000 to build a flagship machine meant to conquer its entire passenger network. Instead, the longest passenger steam locomotive ever built was trapped on a narrow slice of track in Ohio and Indiana. It could not enter the tunnels to Manhattan, it could not traverse the curves of the Pennsylvania hills, and it could not even fit inside standard roundhouses for maintenance. The S1 was designed to dominate the rails, but its own extreme scale had turned it into a prisoner of a single flat corridor. On the flat straightaways of the Fort Wayne Division, a different kind of history began to form around the S1, one written not in engineering logs, but in rumors. Over the years, rail enthusiasts and popular articles built a legendary reputation for the engine's speed, claiming it was the fastest steam locomotive ever built. The most persistent story alleges that the S1 reached an astonishing 156 miles per hour on a test run, supposedly shattering the world record held by the British locomotive Mallard. This tale is often paired with an even more colorful legend that the Pennsylvania Railroad was slapped with a massive fine by the Interstate Commerce Commission for speeding because the engine had run so far ahead of schedule. Yet the primary historical record tells a much more grounded story. The Pennsylvania Railroad's official dynamometer car logs, now preserved in the Hagley Museum collection, reveal that the highest speed ever scientifically measured for the S1 was 108 miles per hour during a routine run with a passenger train. Furthermore, the official operating timetables for the Fort Wayne Division capped the locomotive's maximum speed at a strict 100 miles per hour, with average schedules requiring a more modest 63 miles per hour. No physical documentation, strip chart, or official report has ever been found to support the 150 miles per hour claims. Instead, these dramatic figures appear to have grown over decades of retelling, transforming a fast but standard operational capability into a larger-than-life myth that eventually eclipsed the machine's actual, documented performance. Despite these physical limitations, the S1 was not a total failure. On the straightaways of the Fort Wayne Division, the engine proved it possessed genuine mechanical strengths. To the crews who operated it, the locomotive offered an incredibly smooth ride. Its massive weight of more than 1 million pounds with the tender acted as a giant shock absorber, soaking up every bump and vibration from the tracks below. Firemen and engineers noted that at high speed, the S1 rode like a great ship on calm water, completely free of the violent vertical pounding that shook traditional reciprocating steam engines. Much of this stability came from the duplex design itself. By splitting the power between two sets of drivers, the S1 utilized shorter, lighter connecting rods. This eliminated the heavy dynamic augment that battered track and cab alike on older locomotives. When the S1 was in its element, handling a passenger consist on level rail, its massive boiler delivered continuous, effortless power. The primary assignment for the S1 was Train 76, the Trailblazer, a prestigious all-coach luxury streamliner running between Chicago and Crestline. Throughout the demanding years of the Second World War, the locomotive regularly hauled this flagship train, logging up to 10,000 miles a month. The machine did not just run, it performed. For the crews in the cab, the S1 was a source of pride, representing a high-water mark of steam-era comfort. It possessed a grand technical dignity, proving that under the right conditions, this massive experiment could deliver on its promise. The end of World War II rapidly transformed the operating economics of American railroading. With wartime passenger traffic dropping and reliable diesel-electric locomotives arriving on the system, the Pennsylvania Railroad faced mounting financial pressures. The costly, specialized steam giants of the previous decade quickly became liabilities. By June 1946, the railroad quietly withdrew S1 number 6100 from active service. The massive engine, which had once been the celebrated center of a global exhibition, was towed back to the Juniata shops in Altoona, Pennsylvania. But this was not a return to glory. Instead of entering the shops for a scheduled overhaul, the engine was pushed onto a quiet storage track in the outdoor yards. There, It sat completely exposed to the elements, its smooth Art Deco casing slowly gathering soot, rain, and rust. For nearly 3 years, the S1 remained idle. The enormous firebox that had once consumed tons of coal to produce thousands of horsepower grew completely cold. The 7-foot driving wheels, which had spun before millions of captivated fairgoers in Flushing Meadows, rested motionless on the rails, sinking slightly into the dirt of the storage yard. As sleek new diesel electrics took over the premier passenger runs, the silent S1 became an obsolete relic of a rapidly vanishing era. It was an expensive, 600-ton experiment with nowhere left to run. On January 31, 1949, the Pennsylvania Railroad officially retired the S1, striking road number 6100 from its equipment registers. The decision was swift and unsentimental. The railroad's board of directors concluded that the high cost of maintenance, chronic wheel slip repairs, and restricted route usability made keeping the single prototype completely untenable. Within weeks of its official retirement, the railroad sold the S1 for scrap to the Bethlehem Steel Company. The massive machine, which had cost a staggering $669,780 to design and construct just 10 years earlier, was sold for a fraction of its original value, netting approximately $30,000 in salvage metal. In April 1949, the cutting torches went to work at the Altoona yard. Workers began the unceremonious process of dismantling the engine. They peeled away the continuous, wraparound Art Deco shroud designed by Raymond Loewy, sliced through the high-pressure boiler Baldwin had built, and cut the massive one-piece rigid steel frame into small, manageable chunks of scrap. No preservation group, museum, or historical society stepped in to save any part of the S1. Decades later, in 1966, a minor preservation offer was made to the Illinois Railway Museum for a few remaining S1-related components for $3,000. But the museum declined due to the high costs of transporting and housing pieces of an engine that was already long gone. By the end of 1949, the physical structure of the largest passenger steam locomotive ever built had been melted down in the open hearth furnaces of the steel mills. The physical object completely vanished, leaving only paper blueprints, photographs, and memories behind. Today, the physical machine is gone, but the warning of the S1 remains. It proves that even the most brilliant design will fail if it outgrows the world built to support it. As we push modern engineering boundaries, we still struggle to balance radical ambition with practical infrastructure. True greatness requires more than power. It demands harmony with reality. What do you think of this giant's legacy? Let us know in the comments.